Unit 7, Part 8. One more rule I want to remark about when it will be useful is the rule of addition. Okay, addition is a very strange looking rule, right? The rule is, given any formula, again I stress you really need to understand that in its full generality. Given any formula, you're entitled to infer the disjunction of that formula and any other formula. Okay? Or in symbols, given P, you're entitled to infer P or Q. Right? That's the rule of addition. See Klenk's discussion of it. It's a bit strange. Why are you going from something stronger to something weaker? Right? If Bill stole my car, P equals Bill stole my car. It seems unfair to Mike to say either Bill stole my car or Mike. Either Bill stole my car or Mike stole my car. Mike's like, hey, what did I have to do with it? But nonetheless, it is a truth-preserving rule, right? Given that P is true, of course it is also true that P or Q. Why? The truth table for the disjunction is the truth of the first disjunct suffices for the truth of the disjunct, right? So if P is true, for sure P or Q is true. P or Q is also true. So it is truth preserving, and it's going to be very useful in formal proofs. That's what Klenk says. Okay. Let me mention the paradigmatic situation you'll be in when this is going to be useful, right? So it's a rule which entitles you to infer from any premise to the disjunction of that premise and anything else you want, right? So think Q can be any legal formula, right? So here's a legal application of it, right? That's from A, I'm entitled to infer A or, and I'm free here, I'm legitimately applying the rule of addition if I put any formula at all here, right? Whatever I want that's legal, right? Q by conditional E hook G, right? Right, by one addition. That is a correct application of addition. So it sort of allows you to do a lot, but of course the question is, when is it going to be useful, right? When are you going to want to do this? What you really need to know is what's the situation going to be of a proof when it's going to be necessary to pull out this rule, right? I can do that whenever I want, but quite often that's not going to get me anywhere. Okay, so it's going to be a situation like this. So getting that. This is the kind of situation, this is the paradigmatic situation when disjunction is going to be useful, okay? Let me do some working backwards thinking again. Okay, I'll introduce the difference between top-down reasoning and bottom-up reasoning, bottom-up or working backwards reasoning. Top-down reasoning is what I was talking about with regard to conjunction. Top-down reasoning, which Klenk uses a lot of, leading up to proofs especially, is just you look at the premises and you try to see potential applications of rules in the premises. So it's top-down in that you're not looking at the conclusion, you're just deriving whatever you can. Right? You could do addition 100 times if you wanted to, but also you're looking for, if you've got a conjunction, you'll do a simplification, get those things. Right? If you've got a conditional, you'll be looking out for the antecedent of the conditional, can I do a modus ponens, or the negation of the consequent, then you can do a modus tollens. So if you've got that combination of two premises, that's top-down reasoning. But for proofs, really, you need to get in the habit of doing bottom-up reasoning, okay? Bottom-up reasoning is the way you're really going to get through and do and solve most of your proofs, okay? As I said, Klenk doesn't stress it enough, but when she does talk about it, the most important passage from the whole of Unit 7, I think, is this passage here at the bottom of page 136. She introduces, did it focus there? I got underlined here. Okay, this little thought I'm going to repeating many, many, many times here all the way through to Unit 15 and 16 when we do proofs for predicate logic, right? The bottom-up or working backwards method, as the name implies, you start out by considering the conclusion in your reasoning process rather than the premises. Instead of asking what can be derived from the premises, as in the top-down method, you ask, given that this is the conclusion I want, how can I get it? This is the crucial part. What formulas do I need to derive it, and what rule will be applied? Okay? That two-part thought is absolutely fundamental to the doing of proofs, right? So you're gonna see me apply it to bust out that thought hundreds of times. What is it? Okay, this is my formula, right? My question will always be, now I'm gonna say, my question is always gonna be, where does this formula plus or minus a negation appear in the premises? Why plus or minus a negation? Well, because in, say, modus tollens, for example, what's the conclusion of modus tollens? That's P or Q and not Q. It's therefore not P is the conclusion, right? So, especially in conjunction with the Unit 8 rule, we'll see, when we get to Unit 8, the rule of double negation, which is going to be, given any formula, you can double negate it, and you can also go the other way. Right? Given any double negated formula, you can get rid of the two negations. Given that rule, so if for example this was here not E, right, then if I could, right, screw this up. Yeah, let's say if this was not E, right, so bottom-up reasoning, I ask, where is this formula plus or minus a negation of, where does it appear amongst the premises? So here it appears plus a negation, right? My thought would be, I've screwed it up. That's not the one I'm thinking of. Sorry, I'll come back.